Welcome to Maths with EJD. I have another structured question in two parts. The first part says to find the correlation coefficient of variables x and y in the table below. X and y correspondingly with 170, 169, 180, 183, 192, 211, 220, 235, 240, 255, 266, 275, 295, 286, 329, and 290, 350. I want to find the correlation coefficient of variables x and y. Then the second part is with the aid of diagram, highlight the different types of skewness in statistics. So let's go for the first one. Um, and just like I told you, right? Answer like you're telling stories. That's really important. Always answer like you're telling stories. Okay. So I say A to find the correlation, to find the correlation coefficient of variables X and Y. So what you define is what you find, right? You first of all need to know, um, okay, you need to state what you want to use. This looks to me like we should use Pearson. Isn't Pearson, isn't Pearson correlation coefficient? We have the formula to be R equals N multiplied by summation of X, Y minus summation of X, summation of Y all over square roots of square roots of uh N summation of X squared minus summation of X all squared multiplied by N summation of Y squared, okay, minus summation of Y all squared. This is the formula for the Pearson correlation coefficient. And from that alone, you can already see that you need the summation of X, the summation of Y, the summation of X squared, the summation of Y squared, and the summation of X, Y. So you can get the data in that way. So you have, so uh so let's get the data. Let's say X now. You have X, you have Y. So 170, 169. That's the first one. 180, 183. Hope we're in order, yeah. 192,202. 192,202. Next, you have 211,220. 211,220. Then you have 235,240. 235,240. Like that. You have 255,266. 255,266. Then you have 275, 295, 275, 295, like this. Then you have 286, 329, 286, 329. And lastly, you have 290, 350, like that. Let's be sure because errors can be very painful here. 170, 169 correct. 180, 183 correct. Then 192,202, yes. 211,220 correct. 235,240, yes. 255,266, yes. 275,295, yes. 286,329, yes. 290,350, correct. So we can move on. Can go ahead and do what we have to do now. So we need summation of X, we need summation of Y. So with what we have already, we can get summation of X and summation of Y. So next we need X squared. We need X squared. Okay. We need X squared. Then we need y squared. We need y squared. Then lastly, we need xy. We need x multiplied by y. So once we can get all this together, we are good to go. All right, so x squared. So we want to square each value of x. So you have to make sure you confirm right. So nothing goes wrong. So we have 170 raised to power 2. 170 raised to power 2. That is 289. 28900. Okay. That is 170 squared. That's 28900. Then you have 180 raised to power 2. That is 32400. 32,400. Then you need 192 raised to power 2. 192 raised to power 2. That is 36864. 36864. That's this now. Then 211. You need 211 raised to power 2. 211 raised to power 2. That's 44521. 44521. Then you need 235 raised to power 2. 235 raised to power 2. That's 55225. 55225. Then you need 255 raised to power 2. That's like 255 times 255, right? That's 255 raised to power 2. That's 65025. 65025. Okay. Then next you need 275 divided by raised to power 2. That's 275 times 275. That's 75625. 75625. Then you need 286 raised to power 2. 286. A good calculator, without a good calculator, you're going to get into trouble. So be careful to have your calculator handy, a calculator that you have mastered. And it's important that you have practiced this a couple of times before the exam, under exam conditions, if possible. So, because one can easily be thrown off balance with this kind of questions. That's 81796. And then this is 290 raised to power 2. That is 84100. It's 84,100. Okay, that's about x squared. So we do the same for y squared now. So, all this squared already. Then we go for y squared. So for y squared, we have 169 squared. Very big numbers here. 169 raised to power 2. So that is 28561. 28561. And then we have 183. It's this now. 183 raised to power 2. 183 raised to power 2. That is 33489. 33489. Then we have 202 raised to power 2. 202 raised to power 2. That is 4084. 40,804. Then we have 220 raised to power 2. That is 48400. 48400. 48400. Then we have 240 raised to power 2. 240 raised to power 2. That's 57600. 57600. And we have 266. 266 raised to power 2. That's 7756. 7756. That's 266 raised to power 2. All this one now, that's what we're doing. And then we have 295 raised to power 2. 295 raised to power 2. That is 87025. Then we have 329 raised to power 2. 329 raised to power 2. That's 108241. 108241. Then 350 raised to power 2. 350 raised to power 2. That's 122500. 122500. All right, so everything is going. Let's move to x, y. So we multiply x and y together. So for the first one, we have 170 times 169. 170 times 169, that's 28730. 28730. Then 180 times 183. 180 times 183. That is 32940. 32940. 40. Then we have 192, 192, and 202. So 192 times 202, 192 times 202, 192 times 202. That is 38784. 38784. And we have 211, 220. 211, 220. 211, 220. That's 46420. 46420. Then we have 235240. 235 times 240. That's 56,400. I think we've seen this before somewhere, yeah? But whatever. So that's 56400, right? 56400. Then we have 255266. 255 times 266. That is 67830. 67830. Then we have 275295. 275. 275 times 295. 275 times 295. That is 81125. 81125. Then we have 286329. 286 times 329. That's 94094. 94094. And lastly, 290350. 290 times 350. That's 101,500. 101,500. Okay, from the table again, we need summation of x, summation of y, summation of x squared, summation of y squared, and all that. Okay, so we need summation of x. We can put that here. So summation of x, and this is a lot of work, so a lot of carefulness is required. 170 plus 180 plus 192 plus 211 plus 235 plus 255 plus 275 plus 286 plus 290. Okay, that's one. Check again. 170, 180, 192, 211, 235, 255, 275, 286, 290. Okay, that's 2094. 2094. That's summation x. Then summation y is the next. So let's do that also. That's 169 plus 183 plus 202 plus 220 plus 240 240 plus 266 plus 295 plus 329 plus 350. So that's 169 plus 183 plus 202 plus 220 plus 240 plus 266 plus 295 plus 329 plus 350. Okay, I think that's in order. So we have 2254. 2254. Now we need summation of x squared. So that's summing up all of x squared. Again, we have 28900 plus 32400. 32400 plus 36864. 36864 plus 44521 plus 55225. 55225 plus 65025 plus 75625. 75625 plus 81796 plus 84100. Okay, so let's check. Checking is really important because one simple mistake can just cause all the trouble. So 28900, 32400, 36864, 36834, 44521, 55225, 65025, 75625, 81796, 84100. So that's 5504 4, 5, 6. Okay. Then we need the summation of y squared also. Let's go for that now. Y squared, that's 28561. 28561 plus 33489. 33489 plus 4084. 40804 plus 48400. 48400 plus 57600. 57600 plus 70756 plus 87025. 87025 plus 108241. 108241 plus 122,500. 122,500. So we'll check again. 28561, yeah. 33489, 40804, 48400, 57600, 70756, 87025, 108241, 122,500. So that gives 597376. 597376. Lastly, almost there, summation of xy. The summation of xy, we go slowly again and be sure no errors occur. So we have 28730 plus 32940. 32940 plus 38784. 38784 plus 46420. 46420. 46420 plus 56400. 5656400 plus 67830. 67830 plus 81125. 81125 plus 94094. 94094 plus 101500. Okay, so I check again. 28730, yes. 32940, 38784, 46420, 56400, 67830, 81125, 940, 94101, 500. Okay, the total of that is 547823. Yes, that's some serious breakthrough right there. But then we have the last fight. Let's go for the last fight. Um, Let me use, should I keep the black power? Okay, let me go this way. Yeah. So R, so we now say R is N summation XY, right? N summation XY, right? Minus summation X summation Y divided by the square root of N summation X squared minus summation X all squared into N summation Y all squared minus summation Y all squared, like that. So let's just put, okay, we can take liberty to change colors. R is, N is actually the number of data points. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 9. Interesting. Is it 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, so N is actually 9. So we can say N is 9. The number of pair of points, that's 9. So N is 9. So we have 9 times summation of XY, that's 547823. 547823. 547823. Summation X, summation Y, that is 2094 multiplied by summation Y, 2254. 2254. Then square root of 9 multiplied by summation of X squared, 504456. 504456 minus summation x all squared. That is 2094 squared. 2094 squared, like that, into 9 again times summation of y squared. That is 597,376. 597,376. 597,376 minus summation of y, which is 2254 all squared. 2254 all squared. Okay, so things are getting better. So r is equal to, let's go carefully again. That's 9 times 547,823. 9 times 547,823. That is 4. That is 4930. 4930,407. 4930,407. Then next is 2094 times 2254. So that is 4719876. 4719876 divided by square root of, so here now we have 9 times 504,456. So that is 454,0095 minus 2094 raised to power 2. Oh, that's 456, sorry. 456. Okay. Hope I've not made such a mistake before now. This is 454,0104. Okay. Minus, takes a lot of carefulness. 454,0104. Then 2094 raised to power 2. 2094 raised to power 2. That is 438. 438, 4836. Okay. 438, 4836. That multiplied by, now 9 times 597,376. 9 times 597,376. That is 5376384. Okay. Minus 5376384. Then 2254, 2254, 2254, 2254 raised to power 2. That's 2254 times 2254. 2254 raised to power 2. That is 50, 50, 80, 516. 50, 80, 516. Okay, so we move on now to the next step. Then we can subtract. Okay, we just have subtractions and division left. So a bit of multiplication somewhere. So carefully, 49304, 4930407, 4930407 minus 4719876, 4719876. Okay, that is 210531. Things are getting easier. To square root of, so the first bracket we have first bracket we have 454,0104, 454,0104 minus 438,4836. 454,0104, 454,0104 minus 438,4836. That is 155. 268 times, this is like times now, times, we do that again, 537, 537, 6384, 537, 6384, 537, 6384, minus 5080, 516. That is 295868. Okay. R now is equal to, okay, let me change marker here. So R is equal to 210531 divided by square root of, so we multiply that out again. Should we multiply out? Okay, let me try. We've been doing, if it's too long, I'll just take the square root directly. So let me see how that goes. So that's 155,268 times 295,868. This is going to be really long. Okay, not too long, but maybe it's better to just take the square root directly. But let me just write what I have. So 155,268 times 295,868. So that's 4,593,883,2,624. Let me check. 4,593, 4,593, 8,832,624. Looks like a phone number. 4,593, 8,832,624. Okay, so we are getting home gradually. So R is equal to 210531. Now it will be approximated at this point because we'll be taking square root there. So R is approximately 210531 divided by the square root of that long thing. So we have square roots of um square root of 4,593, 4,593, 8,832,624. I check that again, which is crucial. 4,593,8,832,624. Okay, that's now 214,333.461. So now R is finally approximately 210,531 divided by 214,333.461. 214,333.461. So R is approximately 0.9823. So finally we are there. Such a big deal. So find the correlation coefficient. So that's the correlation coefficient. So we can say, therefore, the correlation coefficient of X and Y is 0.9823. Okay. We want to go the extra mile. This shows a strong positive correlation between X and Y, such that as X increases, Y also increases. That's the meaning of that value. Okay, I mean, I'm almost tempted to think we have come to the end of that question, but no, we have a B part because that's really lengthy. Thankfully, the other part is not as long. So the second part is saying is asking us to, with the aid of diagram, highlight the different types of skewness in statistics. Okay. Um, so let's do that. That's B, right? B to highlight the different types of skewness in statistics. First, we need to know first we need to know that skewness measures skewness measures the asymmetry. Skewness measures the asymmetry of a probability distribution. And there are three types. There are three main types of skewness. Okay. First, let's talk about positive skewness. Positive skewness, which can also be seen as right skew. It can be seen as right skew. And for this, the tail, the tail on the right, the tail on the right side of the distribution, the tail on the right side of the distribution is longer or fatter or fatter than the left side. Okay, that's one. Two, the bulk of the values, the bulk of the values lie to the left of the mean, to the left of the mean. So a very good example can be, very good example can be income distribution, income distribution in a population. Of course, we need to see a picture of that, right? It is right skew. So imagine you have this and you have all the data, right? So most of the data is to the left, like we said. The bulk of the values lie to the left. So it means you have something like this. And then you have just few values to the right. So that is why it is said to be a right skew. Okay. Um, that's for positive skew, or what you can call right skew. Then next we have the second type, which is negative skewness or left skew. Negative skewness or left skew. Here, the tail, the tail on the left side, the tail on the left side is or fatter, longer or fatter than the right side. Okay. Then next, the bulk of the values, the bulk of the values lie to the right, to the right of the mean. A very good example of that would be age at retirement, age at retirement. So the bulk of the values will lie to the right of the mean. That's age at retirement is mostly very like maybe high values like 65, 70 and upwards, right? So because of that, see what right skew is, the left skew will be a bit different. So here you have the bulk of the data is here, but then you have few data to this side. So that is left skew. I'm going to show a Python diagram to show this better in case I've not done a very good job. So then we have the third type. The third type is the third type is no skewness. That's three. No skewness, which you can call maybe zero skew, or you can call it symmetrical distribution. Symmetrical distribution. Distribution. Okay, I want to manage my space. Okay, let me just say symmetrical distribution this way. Symmetrical distribution or zero skew. Okay. In that case now, uh, the points are like this. The distribution is symmetrical. The distribution is symmetrical with tails on both sides, with tails on both sides being of equal lengths. Then the other point is that the mean, median, and mode are all equal. A good example of this would be what you get in normal distribution. Normal distribution. Okay. Okay, let me try to represent that as much as I can. So you have something like this. Okay. So that no side is longer than the other. But I mean, to do better justice to this, let me show a Python rendition of this. Um, let's go for that. Let me just start a Python program. Okay. Um, this comes up. Right. So I navigate to the desktop where I have maths with EJD, and then I go to statistics, and then yeah, we have okay, I've even demonstrated that before, measures of shape, but what I'm talking about now is types of skewness, just to show that briefly. Okay, I mean the code may not be that important here. I just want to show the pictures. Okay. All right, so you see the left skewness, so the longer tail, the tail is longer on the left. And symmetrical distribution, you have even distribution, symmetrical distribution. And then on the right, you have, the tail is longer on the right, like that. And that's exactly what the whole idea is about. Thank you so much. We've come to the end of that lengthy question. So, I mean, if you don't want to make mistakes, you need to practice as much as possible, use your calculator. Then another wisdom is in an exam situation, if you have options, you want to avoid questions that will waste your time or questions that will require you to punch your calculator a lot, and you can easily make mistakes. So if you have options, you can actually avoid questions like that. But if you don't have any option, go for it. It's not beyond you. So if you have not subscribed to this channel, be sure to do that right now. And of course, hit the notification bell so you can always get alerted each time a new video is released. And don't forget to comment. Tell me if you want me to solve a problem or treat a particular topic. And don't forget to like and share so that more people can have access to this great learning. Till I come your way again, have a great time. Bye.